STA 3624 Time Series Analysis and Forecasting. Lesson 5, Decomposition of Time Series Models. We have seen that a series can be analyzed into 4 components. Those components are trend component, seasonal variance, cyclic component and irregular fluctuations. So in the decomposition model we have to find those all 4 models. Decomposition model, mathematical representation of decomposition approach is we take the yt as the function of t, s, c and I. Yt is the time series value, it means the actual data at the period t. You observe the value time series at time period t, and also t means a trend component of time t, t means seasonal component in time t, and ct is the cyclic component in time t, and it is the irregular component in time t. So then the decomposition model that is right in these 4 components to predict the yt is the demand. The exact functional depends on the decomposition model actually used. There are 2 models that used to decompose of those time series. The 2 models are additive decomposition and multiplicative decomposition. Additive decomposition in some time series, the amplitude of both seasonal and irregular variance do not change. So if amplitude of both seasonal and irregular variance do not change, then trend rises or falls. In these cases an additive model is appropriate. So if you can see a time series model which amplitude of both seasonal and irregular variance do not change, then that we can use the additive model, right? This model when used time series data exhibit the constant seasonal variance. So we can use this if this is exhibit constant seasonal variation. In this additive model, the observed time series considered to be sum of 4 independent components. So then in additive model we find the sum of 4 independent components. So then this the model yt equals t plus s plus c plus t. We have to add all of these 4 components in the additive model. If the time series if the data do not contain one component, right? If one of the components, for example cyclic component, value of that missing component is 0. So if it is missing, then we taken this value of this missing component as 0. Suppose that there is no cyclic component, then our function is the formula is changed with there are no cyclic component, then c is equal to 0, then it is become like this. Note that in the additive model we assume all the components are operate independently of one another, right? Independent of one another, and behavior of the component is an additive character. So these are the properties of additive model. Then we move to the multiplication decomposition model. In the time series, the amplitude of both the seasonal and irregular variance increase as the level of trend rises. So if amplitude is increase, then within this situation we can use the multiplicative model, right? This this model can be used when a time series exhibiting increasing or decreasing seasonal variation. So in that case we can use the multiplicative decomposition. In multiplicative model, the original time series expressed as the product of 4 independent components. Earlier we represent as addition of 4 independent components. Then here if it is multiplication model, we have to use this as the multiplication of the 4 models. Then model is we can create like this: yt is equals t minus multiplied by s multiplied t multiplied by c multiplied by I. So this is the component. In this the component are necessarily here the components are not necessary to be independent, and they can affect one another. In this model they can affect one another, but in additive model they are independent. If the trend component, seasonal variance, cyclic component is missing, if one is missing, the value is assessed assume to be 1. Earlier, if 1 is missing, we assume to be 0. Now in the multiplicative model, it is assumed to be 1. For example, suppose that it is no cyclic component, then here no cyclic component means C is becomes 1. So then model is come as yt equals tt multiplied by st multiplied by it, right? So this is the model. Then most of the time series related to the economic and business phenomena confirm the multiplicative model. So in the business phenomena and economic, we use multiplicative model. Illustrative example for this is for the additive model. Suppose that the sale of a motor car manufacturing company are seasonal. First quarter lower sales, second quarter higher sales, third quarter moderately high sales, fourth quarter moderately low sales. Assume that they are exhibit a linear trend given by this equation. Equation is given t equals 500 plus 5t. Suppose that the seasonal variance linear trend is given, and seasonal variance for the quarter 1 to 4 is given by s1 equals this value, s2 equals this value, and s3 and s4 is equals those values. Assume that 10t is equal to 0 for fourth quarter of 1992, right? So when t is equals to 0 when fourth quarter of 19, then motor car sales in 4 quarters in 1993 can be forecast as follows. So when t equals 0 for the fourth quarter of 1992, then next to fourth quarter of 1992 come first quarter of 1993. So in the last quarter of the fourth quarter of the 1992 equals 0, the t value is 0. Then what happened to the t value of the first quarter of the 1993? It is becomes 1 because of this 0. Then second quarter 2, third quarter 3. Likewise, then when we can find the trend values for the components by substituting t equals 1 for the first quarter, t equals 2 for the second quarter, t is 3 for the third quarter, and t is equal for the fourth quarter, then when we substitute value of the t for this equation, you can get this answer: t1 equals 550, t2 equals 600, t3 equals 650, and t4 equals 700. That's how we can find the trend component if the equation is given. And next, assume that the seasonal factors are multiplicative. Then it is given the seasonal factors are multiplicative. The combined trend seasonal effects. Then combined effects we can find t multiplied by s. For the first quarter, we found the t values. Here we found the t values t1, t2, t3, and t4 we found, and s values are given here. So we can find t into s1, t2 into s1, t3 into s3, t4 into s4 by substituting the values. Then you can get the answers as 220, 960, 760, and 780, and 560. So you can easily find those values when substituting those for these equations. And assume that there are four quarters of 1993 are included in boom period business cycle, and cyclic factor describing the increasing economic activity in 4 quarters of 1993 are: it is given cyclic component C1 equals 1.06, C2 equals 1.09, C3 equals 1.09, and C4 equals 1.10. Therefore, the forecast for the motor car sales in the quarters of 1993 given below. So if the cyclic component is also added, you have to multiply this all, t into s into c1. So t1 we knew, s1 is given, and c1 now given, right? So then you can multiply these all values, and you can take in this value, first value was 278, 238, then second value 1046, and 850, and 660. Then you can plot expected sale for time t. Then first you can find when t equals 1, the value is 278. When t equals 2, value is 1046. Then t equals 3, value is 850, and t equals 4, the value is become as 616. Then you can see this trend line. You can draw this trend line by using the methods we learned in the previous lessons. So then you can see this trend line is slightly increasing trend. Then multiplicative decomposition model, we can learn step by step. Let L number of periods in year. Then there are 9 steps in the multiplicative decomposition model. So first we identify how we can do the multiplicative decomposition model. Then we can do an illustrative example. Step 1, find the L period moving averages. First you have to find the L period moving average of the time series YT to remove the seasonal variation from YT. Then calculate the centered moving averages if L is even. So in the first step you have to do two things. First one, you have to find the L period of moving average. L is equal to number of periods in a year, and if the L is even, you have to do another thing, centered moving averages. If L is even, no, that is only enough to find the moving averages. If L is even, you have to find the centered moving averages. Step 2, calculate the seasonal ratio RT. Seasonal ratio, next you have to find the seasonal ratio RT to the moving average corresponding to the period T. Third step is calculate the seasonal ratio R bar T for each L seasons. Then you have to find the R bar T for each L seasons, right? Each of L seasons you need to find R bar T. That is the step 3. And step 4, estimate the seasonal factors S and T given by this equation. S and T equals R bar T times L over sigma T equals 1 to N R bar T. So you have to use this equation to find S and T. Then step 5 is compute the deseasonalized data dt by using this equation. In the step 5 you have to find the deseasonalized data. And step 6, find the estimate of TRT, that means the trend line, by using the decentralized data dt, right? Then step 7, obtain the estimate of CLT multiplied by IRT by using the equation CLT multiplied by IRT equals YT over TRT into SNT. So then you can find the multiplication of cyclic component and irregular component by using this equation. Step 8, estimate the cyclic factor. Then you can find the cyclic factor by averaging the corresponding CLT into IRT. Here you need to find the 3-year moving averages to find the CLT. And step 9, estimate the irregular movements in the time series by using this equation IRT equals CLT multiplied by IRT divided by CLT. Then now you found all the 4 components: cyclic, trend, irregular and seasonal variance. So now it is completed in the multiplicative decomposition model. Now I roughly explain how you can find this. Now these components, now we will see through an examples how you can do this. This is the example. Consider the following data concerning a quarterly demand for seminars by given interested group of people over the last 4 years. Develop a multiplicative decomposition seasonal model for this problem. So you need to develop a multiplicative seasonal model for this problem. Now these are the data. So there are 4 years, 1, 2, 3, 4, and each year containing 4 quarters. It means 4. So if 4 quarters for years, I explained earlier, then what is L? L is this one. L is the periods in year. There are 4 periods in year, then it means L equals 4. If we take year once a month, then it means there are 12 periods per year, then L equals come 12. For this question, L equals 4. Alright. So now next we then solving this problem means you have to find you have to fill this table. Then here you can see you can find a seasonal factor here, right? Then trend component here, then cyclic component here, irregular component here. So you need to find all of these components in the multiplicative model. Then to do this, you have to fill this table, right? So in the first column you can see year. There are 4 years, right? So you can see year 1, 2, 3, 4. And in the second one, quarters, 1, 2, 3, 4 for the first year, 1, 2, 3, 4 for the second year, then 1, 2, 3, 4 for the third year, and 1 2 3 4 for the fourth year. Then here you can you have to fill the period. How you can fill the period is you have to start from 1 2 3 4, right? Then 5 6 7 8 9 10 11 12 13 14 15 and 16, right? Then now you found the period T is 1 to 16 because there are 4 years. For 1 year there are 4 quarters. Then you have to just put numbers 1 to 16. Then demand is given in the questions, right? So you can find the right demand here given 10 31 43 16 11 33. Likewise you can add for you can add to this column YT. Demands given 10 31 43 31 43. Likewise you can add for this column. Then next thing is the first step, estimate the seasonal factors for each quarter, calculate the moving average of each time series to remove the seasonal variation from the time series. The first step is you have to find the moving averages. So when I explaining the theory, I told that you have to find the L-year moving averages. Then here L equals 4, then it means you need to find the 4-year moving averages, and also this is even number 4, then you need to find the centered moving average also. Moving average is calculated by adding the observation for number of periods in the time series and divide the results by the number of periods included in the average. For the seminar demand problems, it means for that problem we choose L equals 4 since we have quarterly data. The time series consisted of 4 of monthly data. When L equals 12 would be used. So moving averages here, then how we see how we can find the moving averages. So we have to consider first 4 years, no, here 10, because we need to find 4 years moving averages, no. Then what are the first values for demand in first 4 years? That is 10 31 43 and 16. We have to add this all, then divide by 4, right? So we can find the moving average 1 to 4, right? So we are going to find moving average for 1 to 4, right? Then it's become, we need to add these values. 10 plus 31 plus 43 plus 16 divided by 4, right? 10 plus 31 plus 43 plus 16 divided by 4. 10 plus 31 plus 43 plus 16 divided by 4. Value equals 25, right? So then moving average 1 is come as 25. So it is we have to put in center of these 4 entries here 10 31. Then it means the center is here in between 2 and 3. Then what you have to do in the next step, you have to remove this 10, right? Then you have to take the other 4, right? It means 31 43 16 11. Then you have to find you have to divide this by 4, then you can find the moving average for, then you can find moving average for 2 to 5. Then what are the values? 31 plus 43 plus 16 plus 11 divided by 4. Then 31 plus 43 plus 16 plus 11 divided by 4. Then 31 plus 43 plus 16 plus 11 divided by 4. Then it is come 25.25, right? So we can add for here 25.25, right? Next what you have to do, you have to omit 31 and you have to consider this 4. Then you can write the moving averages, moving average from 3 to 6 is equals 43 plus 16 plus 11 plus 33 divided by 4. right? So 43 plus 16 plus 11 plus 33 divided by 4, then answer is become as 25.75, that is 25.75. then you can add for here 25.75. likewise you can continue the procedure and take the values for the moving averages for these remaining rows as this. Right, these are the values for this column, right? Then next we have to do is, I explained you also, this is a even number. Then what you have to do is, L is even, you need to find the centered moving averages. So right, so then we have to find the centered moving average. So first centered moving average is come for here. It means when t equals 3, no, then first we can find MA CMA3, then you can find a CMA centered moving average 4, CMA 5. So to find the CMA3, what you have to do is you have to center these two, right? It means you have to add these two values and divide by 2, then you can find the centered moving average for this one. Simply 25 plus 25.25 divide by 2, right? It means you can find a centered moving average 25 plus 25.25 divided by 2. So then you can find the centered moving average as 25 plus 25.25 divided by 2, that is 25.125, right? So you can add this for this here, 25.125. to find the next centered moving average, you have to consider this to 25 plus 25.75 divided by 2, then 25 plus 25.25 plus 25.75. now you have to consider these two values divided by 2, then 25 plus 25.75 divided by 2, then 25.25 plus 25.75 divided by 2, then value is 25.5, right? Then here you can add 25.5. for the next value you have to consider 25.75 and 26.25, right? 25.75 plus 26.25 divided by 2 then 25.75 plus 26.25 divided by 2 then value is come as 26, right? By following this procedure you can find the other values also. Those are come as right. Now you fill that column also, that is centered moving average. Then next you can find the seasonal ratio, right? So then that's we did. Since L is even, we next calculate the centered moving average CMAT. the centered moving averages have to remove the seasonal variant from the data. Now we found the centered moving average. Then calculate the seasonal ratio RT. So by using this equation, RT equals YT divided by CMAT, right? So now we can find RT, that is seasonal ratio, by using this equation, YT divided by centered moving average is CMAT. right? So if we need to find first, what is we can find, uh, here we can find 3, no, then we can find R3, right? So we can find R3 Y3 divided by CMA 3, right? R4 we can find Y4 divided by CMA 4, no? Then R5 we can find Y5 divided by CMA 5, right? Now we can simply substitute the values from the table and find the value for the R. So then here first we need to find YT over CMAT. YT for this one, Y3 is 43, CMA3 is 25.125. so then it means R3 equals 43 divided by 25.125, right? 43 divided by 25.125, then it is come 1.71. 1.71. To find R4, that is Y4 divided by CMA4. Y4 is 16, CMA4 is 25.5. It means 16 divided by 25.5. 16 divided by 25.5. Value is 0.627. It means 0.63, right? Here 0.63. Then to find R5, it means Y5 divided by CMA5. It means 11 divided by 26. 11 divided by 26. Value is common 0.42, right? That is 0.42. Likewise, you can find the other values as now we filled this column, that column also, right? So now we can find the seasonal factor.